Solve problem number 6, the homework 9. Step 1 is to write the equation in standard form, which we can check because that's already written in standard form. For step 2, we need to write the equation in the operator form, and for this equation that's going to be d to the fourth, because the original equation says y to the fourth prime, minus 2d squared, and that's for the 2y prime there, plus 1 of y is equal to e to the x, because of the e to the x here. Step 3 is to just write the homogeneous version, which is the same operator as above, except set it equal to 0. For step 4, we have to solve the homogeneous version, and for that we basically change this to be m to the fourth minus 2m squared plus 1 equals 0. That's going to factor to be m plus 2 minus 1 squared, or m plus 2, or m squared minus 1 times m squared minus 1 equal to 0, and that's going to leave us with m equals plus and minus 1 as well as another plus and minus 1. So we just found that with m equals 2 plus and minus 1s, so that's going to give us the fundamental solution here with base h is equal to e to the x, comma x e to the x, comma e to the negative x, comma x e to the negative x. So now that we have that, we can find our y of c, which is going to be equal c1 e to the x plus c2 x e to the x plus c3 e to the negative x. Down here I'll write plus c4 x e to the negative x. Now this is going to be important because we're going to need this for our final answer later on. So I put our original equation back up here, and this e to the x is going to equal our g of x, and step 5 equals finding the annihilator of our g of x. And in this case, since it's just e to the x, our annihilator is equal to simply d minus 1. Therefore, our a of d is equal to d minus 1. And to finish step 5, we need to find a of d times f of d of y equal to 0. Now, f of d was just the original equation we found before. So when we put it all together, we get our d minus 1, which we just found, multiplied by the original d to the fourth minus 2d squared plus 1. And again, that's what we found earlier, and just keep it there with a y, and then set it back equal to 0. Now, we have to essentially find the characteristic equation of that, which basically means we'll go ahead and replace the d's with our m's, and we're left with m minus 1 multiplied by m to the fourth minus 2m squared plus 1 equals 0. And of course, looking at this here, we can tell that our m is equal to 1, and we already found what the m's equal before with this side, and we know that that was 2 plus and minus 1s. So I'm going to go ahead and write our 2 1s and then our 2 negative 1s. That is going to give us the fundamental solution with the base nh of e to the x, comma x e to the x, comma x squared e to the x, comma e to the negative x, comma x e to the negative x. So I rewrote both our FSNH and our FSH here because step 7 is finding FSNH minus our FSH. So if you look at the original problems up here, you see our e to the x's cancel out, our x e to the x's cancel out, our x e to the negative x cancel out, and our e to the negative x cancels out. So that means that we are left with x squared e to the x. This means that our y of p equals a x squared e to the x. Now step 8 is plugging y of p into the original equation in order to find what a equals. Now I went ahead and wrote all my work here and how I found the derivatives of y of p, because we're going to have to need the fourth derivative for this part, the second derivative to plug in here, and then we plug in the original into here. And this is just basic product rule in order to find the derivatives. So now that I found those, I plugged them into the original equation, and since that work got kind of messy, I hand wrote it and put the picture out here. You can see we have our y to the fourth prime minus 2 times y times the second prime, and then we have our original. And then you see here I circled the terms that match up. For example, here we have our ae to the x and our ae to the x. We have our 8ax e to the x and another ax e to the x, and then we have our x squared e to the x's over here. And if you look, these will cancel out, these end up canceling out, and then you're left with 12a e to the x minus 4a e to the x, which simply equals 8a e to the x, and of course we still have our e to the x on the other side. And if you simplify further, you're left with 8a equals 1, and then of course a equals 1 over 8. We can plug that a into here, and that leaves us with our y of p is equal to 1 over 8 x squared e to the x. Okay, so now we're ready for the final step, step 9, which is to write the general solution, which is y equals y of c plus y of p. If you go back earlier and look at our y of c, it equals c1 e to the x plus c2 x e to the x plus c3 e to the negative x plus c4 x e to the negative x. That all equals our y of c. Now we can go ahead and add in our y of p, which simply equals 1 over 8 x squared e to the x. And this is our final solution to problem 6 for homework number 9. Thank you.